All right, guys, this is part 2. I needed to end the other one. I think we all needed a little break. All right, so let's look at what we have here. So here we have a couple of terms. It says, let's distinguish between 3 vocabulary terms related to fractions. So I've been talking about 3 different things. I've been talking about least common denominators, which it's exactly the same thing as least common multiple, except that it's dealing with fractions specifically. And then I've also talked about common denominators. So, like I said in the last video, as long as your 2 fractions, if you can find a common denominator between the bottom numbers, then you'll get the right answer eventually. If you go ahead and start with the least common denominator, it kind of saves you a little more work at the end of the problem from simplifying it. But either way, you'll get the right answer. So for example, let's look at this first problem, 1/2 plus 1/8. Well, the first thing they did was, if you look at step 1, they identify that these do not have common denominators. So for step 2, it shows that the 2 denominators, 2 and 8, were multiplied together, which gives us a common denominator of 16. So when you add 8/16 plus 2/16, you ended up getting 10/16. But since 16 wasn't the least common denominator, you have to simplify at the end, and we got 5/8, which is the right answer. So that works. So here we take the same problem, and instead of using 16, let's, and like I said, 16 worked, but the least common multiple of 2 and 8 is actually 8. Let me move this down a little bit. So since 2 will go into 8, you'll see at the end it saves us a little more time to use the least common multiple. So 8 is the least common multiple, so it says solve the problem using 8. So instead of 1/2, we're going to have something over 8 plus 1/8. We're not going to change the second fraction. Well, how do we get from 2 to 8? We would multiply 2 times 4. If we multiply the bottom times 4, we have to multiply the top times 4. So 1 times 4 is 4. So then we add our numerators, and we get the correct answer of 5/8, which is what we got. It uses 16, but at the end we had to simplify. So the point is, as long as you have a common denominator, you'll still get the correct answer. You just might have to do a little extra work if you don't find the least common denominator. All right, so here's 3 types of problems that you'll come across. Example 10 says, what if the numerator ends up being 0? Well, so let's work this out and see what happens. So since 5 will go into 15, we're going to use, we're going to use 15 as our denominator. It's being very picky with me right now. Why? All right, sorry about that. Maybe it'll work this time. All right, so since 5 will go into 15, we're going to use 15 as our denominator. So 5 times 3 is 15, so we're going to multiply the numerator also by 3. So 3 times 3 is 9. So then our first fraction is 9/15, and our second fraction that we're subtracting is 9/15. So the rule is leave the denominator the same and subtract the numerators. Well, 9 minus 9 is 0. Well, then to simplify 0 over 15, you would divide 0 by 15, and that is a real answer of 0. Or just think about it. If you start out with 9/15 of anything and you take 9/15 away, you end up with nothing. Then it asks, what if your numerator ends up being the same as your denominator? For example, on this problem, we would use a denominator of 8. So since 4 times 2 is 8, we're going to multiply 1 times 2 and get 2. So we end up with 8 over 8. Well, we simplify 8 divided by 8. Of course, we get the number 1, and that would be our final answer. Letter 12, or number 12, I should say, example 12. What if your numerator is a multiple of your denominator? All right, so let's see what that means. Well, first of all, let's make these mixed numbers into improper fractions. So we're going to multiply 3 times 2, add 1, you get 7/3, plus 6 times 3 is 18, and 18 plus 4 is 22, 6. Well, our denominator, 3 will go into 6, so we're going to use 6 as our denominator. This one won't change. Well, 3 times 2 is 6, so 7 times 2 is 14. And when we add our numerators, we get we get 36 over 6. Well, 36 divides evenly by 6. So 36 divided by 6 is 6. You don't need to write 6 over 1 because 6 divided by 1 is just 6. So these are 3 special types of answers that you will come across for sure. You might get the answer of 0, you might get the answer of 1, and you might get a whole number. So that will happen. All right, so I have given you some try problems, and then we're going to get into some application problems. All right, so go ahead and try those 13, A and B. Pause the video, try it, and then come back to see if you got the right answer. All right, so letter A, we're going to make these improper. So 3 times 4 is 12. 12 plus 2 is 14. So 14/3 minus 18 plus 4 is 22. 22/6. Well, 3 will go into 6. So 3 times 2 is 6. So 14 times 2 is 28 minus 22/6. And of course, 28 minus 22 is 6. So what's our final answer? 1. Good. All right, so if we make these both improper, we have 12 plus 1 is 13/3. 13/3 plus 2 times 3 is 6 plus 2 is 8/3. Oh, I like this problem. It already has common denominators. So now all we do is add 13 plus 8, and we get 21 over 3. Well, 21 divided by 3 is 7. So our final answer is 7. Here our final, for letter A, our final answer was 1. Now we're going to look at some application problems, which means word problems, which everyone hates word problems, but we're just going to do them. Let's just go. So for 5, it says solve each of the following application problems using the 5-step process illustrated in the lesson. Leave final answers in mixed number form if possible. So if Josh ate 1/4 of a pizza, what fraction of the pizza is left? So remember, our denominator tells us how many slices we cut our pizza into. So we have a pizza that's been divided into 4 slices, and Josh ate 1 of them. So you can see from our picture pretty quickly what's left. Well, if he ate 1 of them, that means 3 parts are left out of 4. Or if you think of a whole pizza that's been divided into 4 slices, how many slices would make up the full pizza? Well, that would be 4/4. 4/4 is equal to 1. We're talking about 1 whole pizza. Josh ate 1/4 of it, and he left 3/4 of it. How much is left? You have to subtract from 1 whole. And in this case, 4/4 represents 1 whole. So the answer is 3/4. Letter B, if I drove 10 2/3 miles one day, 12 1/4 miles the second day, and 8 1/5 miles the third day, how far did I drive? Well, each day we're adding miles. So on the first day, we drove 10 2/3 miles. The second day, we're driving 12 1/4 miles. And the third day, we're driving 8 1/5 miles. All right, so on all of these problems, I have told you to go ahead and make them improper and then find common denominators. It's always important, especially to do that for subtraction problems, because subtraction problems can start being complicated if you don't do it that way. However, with addition problems, you can go ahead and leave them as mixed numbers. Go ahead and find common denominators, and then deal with the fraction at the end if it's improper. So for example, let's look at the denominators 3, 4, and 5. And by the way, if you change these into improper fractions and then find common denominators and then simplify, you're going to get the same answer. All right, so 4, 5, and 3. So let's go ahead and list some multiples. So 3 times 1 is 3, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6, 7, 8, 9, 10, let's see, I don't know what we're gonna get. Why don't we try multiplying these together? So 5 times 4 is 20, and 20 plus 3 is 60. So I think that's what's, we could list these on and on and on, but we're gonna have to list a lot of numbers. So we're gonna go ahead and just multiply these together and use a denominator of 60. All right, so anyway, let's leave them as mixed numbers this time. So let's do 10 and something over 60 plus 12 and something over 60, and then 8 and something over 60. All right, so how do we get from 3 to 60? We multiply 3 times 20. So we're going to multiply 20 times 20 and get 40. How do we get from 4 to 60? Well, I'm pretty sure it's 15. 15 times 4, that's exactly right. So I'm going to multiply 1 times 15. And then finally, what times 5 is 60? And that would be 12. So I'm going to multiply 1 times 12. All right, so since I left them as mixed numbers, I'm going to go ahead and add the whole numbers. So the whole numbers are 10, 12, and 8. And I get 30. Now let's add our numerators. So we're going to add 40 plus 15 plus 12, and I got 67. All right, so for just a second, we're going to completely ignore the 30. Pretend like you don't even see the 30. Let's deal just with this right here first. Well, this is an improper fraction. So 60 will go into 67 one whole time with 7 left over. So just this part of the fraction, just this part of the number equals 1 and 7/60. But remember, we still have to add the whole number 30. So the final answer is 31 and 7/60. So if you're adding mixed numbers, you can leave those as mixed numbers and find common denominators, and you'll end up getting the same answer. Okay, I'm just looking at my answers real quick, and I just wanted to double check, make sure I gave you the right answer. 31 and 7/60. Yep. I don't want to give you incorrect information. Okay. All right, let's look at the next question. Melody bought a 2-liter bottle of soda at the store. If she drank 1/8 of the bottle and her brother drank 2/7 of the bottle, how much of the bottle is left? How much is left? Well, let's first of all figure out how much she and her brother drank all together. So in math, when you hear the word all together, that means addition. So she drank 1/8 of the bottle and her brother drank at 2/7. So we're going to find common denominators. So 8 times 7 is 56. So 8 times 7, so I'm going to multiply 1 times 7. And then 7 times 8, so I'm going to multiply 2 times 8. So we see how much they drank all together. So 16 plus 7 is 23. All right, so we can't simplify that. 23 is prime. 56 is not prime, but since 23 is prime, that means they don't have any common factors. Now, they drank 23 out of 56 parts of the bottle. This is irrelevant. This 2 liters, this is basically 1 full bottle of soda, right? So we're talking about one full bottle. We're not worried about how many liters. We're talking about one full bottle. Well, if we took a bottle of soda and we divided it into 56 parts, how many parts would represent one whole bottle? Well, the whole bottle would be 56 out of 56. So if we started out with 56 out of 56 and Melanie and her brother drank 23 out of 56, then to find the answer, how much is left, you have to subtract. So 56 minus 23 is 33. So 33/56 is left. Let's see what my little answers say. Now your answers are also on Blackboard, and I just always want to double check when I do word problems because I don't like word problems either. I like to double check my answer. So that's exactly right. So 33 out of 56 is left. So first you find out how much they drank in all or in total, and then you have to subtract from 1. And in this case, 1 was represented by 56 over 56. All right, let's see what D says. James brought a small bag of carrots for lunch. So one whole bag of carrots included 6 carrots. So one bag, let's go ahead and draw a picture. Y'all are going to see what kind of artist I am. This is my carrot, and this is, never mind. I'm just going to do this for my carrots. I'm not even going to pretend. Is that 6? 1, 2, 3, 4, 5, 6. Okay, here's my 6 lovely carrots. So let's see, is it possible for him to eat 2/6 of the bag for the morning snack and 5/6 of the bag at lunch? Well, there's a couple of ways of thinking about this. So first of all, without even thinking about how many carrots are in the bag, if I wanted to see how many carrots he ate in all, or how many parts of the bag he ate in all, excuse me, I would get a number greater than 1, right? That would mean that James would have to eat more than 1 full bag of carrots because this is an improper fraction. It means it's more than 1. So I know immediately the answer is no because he only has 1 bag and this is more than 1. Or I can use my beautiful example. And if in the morning he ate 2 out of these 6 carrots, that only leaves 4 in the bag. So in the afternoon, could he eat 5 out of 6? No, there aren't 5 out of 6. There's only 4 left. He would have to get a whole nother bag in order to eat 7/6 bags of carrots. So the answer is no, because that's more than 1 bag. All right, letter E. Suppose that David is able to tile 1/4 of his floor in 3 hours. How long would it take him to tile the rest of the floor? Use addition to solve this and not multiplication. So if David was tiling and he completed 1/4, so basically if we take the tile job and we divide it into 4 equal parts, which mine is obviously not 4 equal parts, but pretend it is, it took him 3 hours to tile this part of the floor. Well, if he tiled another 1/4 or half the floor, that would take him 6 hours, because this would also be 3 hours. What about, so this is another 3 hours. This is another 3 hours. Stop it. What about the next 1/4? Well, the next 1/4 would also be 3 hours. And finally, the 4th 1/4 would be 3 hours as well. So all together, all day, or how many hours total it would take him to do the entire floor would be 12 hours. But it doesn't ask how long did it take him to tile the entire floor. They said, what about the rest of the floor? In other words, they're not counting this first part. They already know that took him 3 hours. Well, if we wanted to go back and say, well, the rest of the floor took 9 hours. Or you could have just not counted that first 3 and just added 3 plus 3 plus 3 because you had 3 more 1/4 to tile. All right, hopefully that made sense. All right, so I keep getting in the way over here. On the left side, explain the mistake made in the problem. On the right side, work the problem correctly. All right, so let's see what happened right here. Can you guys see why this is wrong? This is the wrong answer. It's wrong because you're not allowed to add without common denominators. So not only did they add without common denominators, but they added those two uncommon denominators. You never, never, never do that. So 3 plus 5 is 8. That's true. 3 plus 5 is 8, but 2/3 plus 1/5 does not have a denominator of 8. So it says we want to work the problem correctly. So the least common multiple of 5 and 3 is 15. So 3 times 5 is 15. So we're going to multiply 2 times 5, get 10. 5 times 3 is 15. So we're going to multiply 1 times 3 and get 3. And so the final answer should be 13/15. 13/15. All right, let's see. On a recent trip, Robert flew 4 2/3 hours on his first flight and 12.5 hours on his second flight. How many hours was he in the air? Leave your final answer as a mixed number. So what are we given? We are given the hours for each flight. So what is our goal? To find the total hours. So what's our math work? Well, we're going to add our first set of hours plus our second set of hours. So then, since we're adding, we can leave these as mixed numbers. Let's go ahead and do that. So 3 and 2, our least common multiple is 6. So we're going to have 4 and something over 6 plus 12 and something over 6. So we get from 3 to 6 by multiplying by 2. So 2 times 2 is 4. We get from 3 to 6, I'm sorry, from 2 to 6 by multiplying by 3. So 3 times 1 is 3. We add our whole numbers and we get 16. We add 4 and 3 and get 7. And then we have to deal with this improper fraction. So just looking at the improper fraction, 7, 6, 6 goes into 7 one time with 1 left over. And then finally, make sure you add your whole numbers. So the final answer is 17 and 1/6. 17 and 1/6. I would go back and double check my answer. Absolutely, always do that. And then the final result in a complete sentence, it took, or let's say Robert flew a total of 17 and 1/6 hours. Or I should have said he was in the air. How many hours was he in the air? Robert was in the air for a total of 17 and 1/6 hours. That would be a better sentence. All right, so the last little thing we're going to talk about is order of operation. So hopefully you remember either the word PEMDAS, P-E-M-D-A-S, PEMDAS, or a lot of you learned the acronym. Is it an acronym if it's a sentence? Please excuse my dear Aunt Sally. So this tells you in what order to solve a math problem. You always have to follow the order of operation. P means you always start with parentheses and do those first. E means if you see exponents after parentheses, you would do that next, that part of the problem next. M and D, even though M is above D when it's written this way, they have the same value, which means you multiply and divide in order from left to right in the math problem. Well, that's also true with adding and subtracting. So for example, if I had 5 minus 6 plus 1, I would always do whatever comes first in the problem. So in this situation, I would subtract first and then I would add 1. Okay, same thing with multiplication and division. If I had 20 divided by 5 times 2, I would have to do this part first because it comes first in the problem with multiplication and division. All right, but anyway, we haven't gotten into multiplication yet, make multiplication and division. So we're going to look at parentheses and adding and subtracting. So on letter A, we're going to literally do this in order from left to right. So since it's all addition and subtraction, subtraction, you do whatever comes first from left to right. All right, so the first thing we need to do is find a least common multiple. So I know that 8 times 5 is 40. And of course, 4 goes into 40. So we're going to use a common denominator of 40. Oops. All right, so 8 times 5 is 40. So we're going to multiply 5 times 5. 4 times 10 is 40. So 3 times 10 is 30. And 5 times 8 is 40. So 4 times 8 is 32. So immediately I want to go, oh, 30 minus 32 is -2, but we have to go from left to right. So let's say 25, so we're adding our numerator. So 25 plus 30 is 55, and 55 minus 32 is 23. So our final answer is 23/40. 23/40. All right, letter B. So we're going to do parentheses first. That's what the P means. Do parentheses first, and then after we do both sets of parentheses, then we're going to subtract them. Okay, now this is a little confusing because there's no fraction. So you can't just say 3 minus 1/4 is 3 1/4. No, you're actually adding if you do that. So you got to think about this as 3/1. And then you have to find common denominators. So 3/1 can be written, 3 is written the same as 3/1. They're equivalent. So now we have to find a common denominator of 4. Since 1 will go into 4, we're going to use 4. So the second fraction doesn't change. Well, 1 times 4 is 4, so we're going to multiply 3 times 4, and we get 12/4. Isn't that equal to 3? 12 divided by 4 is 3. All right, so 11 minus 1 is, 12. 12 minus 1 is 11. Oh, my pen's messed up again. There we go. 11/4. And now we're ignoring that subtraction sign right now because now we have to do what's in these parentheses. Well, 3 goes into 15 5 times. So we're going to multiply 1 times 5, and we get 5 plus 1/15. Well, 5/15 plus 1/15 is 6/15. All right, now we're allowed to subtract, but we can only subtract if we have common denominators. So let's just go ahead and multiply 4 times 15, and we get 60. So we're going to use 60. Well, 11 times 15 is 165. 165, because we multiply both of these times 15, minus, it's 15 times 4, that is 60. So now we're going to multiply 6 times 4 and get 24. 24. And now we're ready to subtract. 165 minus 24 is 141. 141. So let's see, 141, 60 will go into 141 2 times. So 60 times 2 is 120. So our remainder would be 21/60. And it might look like we're right. We're done. However, 21 and 60 are both divisible by 3. Because if you add their numbers, 2 plus 1 is 3, and 6 plus 0 is 6. Both of those numbers are divisible by 3. So I can simplify this. So I'm going to simplify by dividing 21 and 60 both by 3. And I get 21 divided by 3 is 7. And 60 divided by 3 is 20. So my answer is 2 7/20. 2 7/20. All right. Number 17, perform the indicated operations. Write your answer in simplest form. If applicable, write your answer as both an improper fraction and a mixed number. Okay, so, and I think I gave you some more practice problems to do. I did. All right, so go ahead and pause the video. I want you to try 17 and these practice problems, and then come on back and make sure you get the right answers. All right, so on number 17, we're going to use a denominator of 15. So we have 3/15 plus 1/15, and that's 6/15. And we're going to subtract 7/8 minus 2/8, and we get 5/8. All right, so then a common denominator, 15 and 8, is going to give us 120. There might be a smaller denominator, but I don't know. So anyway, we'll use 120. So 120 minus 120, well, we're multiplying by 8. So 6 times 8 is 48. We're multiplying by 15 over 15, and 15 times 5 is 60. Am I getting a negative number? I didn't think we were using negatives yet. Let me double check this, because I'm getting negative 12 over 160. This is number 17, or maybe I don't have this problem. I don't have this problem. Okay. Oh, look what I did, you guys. I wrote subtraction. It's addition. Okay, I was wondering why I was getting a negative number. I shouldn't have. All right, so anyway, sorry about that. So if I add these, I'm going to get, let's see, 60 plus 48 is 109. So we end up with 109 out of 120. And I don't think that can be simplified. I know that 109 is not divisible by 3, and neither is 120. They're not both even. They don't both end with a 5 or 0. So I think that's good. I think that's the final answer. All right, number 4, we're going to add and subtract in order from left to right. So for number 4A, we're going to use 12 as the least common multiple. So 2 times 6 is 12. So 6 times 1 is 6. 3 times 4, so 4 times 1 is 4. And 4 times 3 is 12, so 1 times 3 is 3. So 6 minus 4 is 2. And 6 minus 4 is 2/12, and 2/12 plus 3/12 is 5/12. That is the answer. All right, so for letter B, we're going to change that to 2 over 1. So then our least common multiple is going to be 5. So the second one doesn't change. So 1 times 5 is 5. So 2 times 5 is 10. So our final answer is 2/5. All right, our least common multiple is going to be 12. So 3 times 4 is 12. 4 times 2 is 8. We're going to multiply by 4. 4 times 1 is 4. And then finally, 1 times 3 is 3. So 8 plus 4 is 12/12. 8, 9, 10, 11, 12. 12/12 minus 3/12 is 9/12. Well, those can be divided by 3. So our final answer is 3/4. 3/4. That's our final answer. And then finally, we're going to put 2 over 1. So that becomes 6 over 3. 6 over 3 minus 1/3. And then we're going to add that to times 5. 5 times 2 is 10. 10/15 plus 1/15 is 11/15. So 6/3 minus 1/3 is 5/3 plus 11/15. And then we're going to use a denominator of 15. So 11/15. So then 3 times 5 is 15. So 5 times 5 is 25. And now we finally add and we get 36/15. 15 will go into 36 twice with 6 left over. And then 6 and 15 are both divisible by 3. and we get 2/5. 2 2/5. All right, let me check these last couple of answers. I think I didn't print the last page, so I don't have that. Oh, well, wait. Nope, that's it. All right, so the very last thing I wanted to end with is a reminder on what is due. So you have till the 15th of June to do my no-show quiz, and Intro to My Open Math is due by June 15th. Your homework and quiz for 1A should have already been completed. And then homework and quiz for 1B is due by Monday before 6 o'clock. At 6 o'clock on Monday, you have to log into Blackboard and take your test between 6 and it expires at 7:30, even if you're not completely done with it. So please give yourself plenty of time and go ahead and log on at 6 o'clock. Okay, so anyway, I will see you guys at the Collaborate meeting tonight. If you feel like you need to come, ask me questions, let me work out some problems for you. And if you feel like you don't need to come, then that's completely up to you. We don't really take attendance, so, but that's the time to ask me questions, to make clarifications, to make sure you have everything you need to have done. So anyway, so I will see you guys tonight at 6 o'clock. Let me stop sharing. All right, goodbye.